Hi guys, hope you all are doing good. So in our previous videos we have discussed about quick slot, met slot and bubble slot. So in this today's lecture we are going to learn another very important slotting algorithm and it is called insertion slot. Insertion slot. So by the end of this video you will understand what is insertion slot is, how it works, step by step example and algorithms and time complexity. So without any delay, let's begin. So first we're going to see what is an insertion slot. So imagine you are playing cards with your friends. So when you receive cards, you don't slot all cards at once. So you pick one card and place it in correct position among the already slotted cards. So insertion slot works in exactly the same way. So it takes one element at a time and inserts it into its correct position. So let me give an example. Suppose we have the numbers 5, 3, 4, 1 and 2. Our goal is to write 1, 2, 3, 4, 5. So this is our goal. So let's see the pass one. How we gonna pass? So pass 1. So our current array is 5, 4, I mean 5, comma 3, comma 4, comma 1, comma 2. So suppose let us take 3. So compare 3 with 5. Since 3 is smaller, move 5 to the right. Insert 3 before 5. So array becomes now 3, 5, 4, 1, 2. So this is our pass 1. So let us see the pass 2. So now we are going to take 4. So compare 4 with 5. So 4 is smaller than 5. So moves 5 to right. So compare 4 with 3. So 4 is greater than 3. So insert 4 after 3. So now array becomes 3, 4, 5, 1 and 2. So we have successfully passed 2. So now we are going to pass 3. Pass 3. So now we are going to take 1. So compare with 5. So move 5 right. Compare with 4 again. So we are comparing with 4. So now move 4 to the right because 4 is greater than 1. So now we are comparing with 3. So move 3 to the right. Insert 1 at the beginning. So now the array becomes 1, 3, 4, 5. So sorry, 1, 3, 4, 5, 2. Let me write. It becomes 2. Sorry. 1, 3, 4, 5, 2. So we have successfully passed 3. So now we are going to pass 4. So now we are going to take 2. So now compare with 5. So 5 is greater than 2. Move it to the right. So it goes here. And compare with 4. It gonna goes right. And compare with 3. It gonna goes right. So now the 2 is compared with 1. 1 is less than 2. So now the array becomes 1, 2, 3, 4, 5. So array becomes 1, 2, 3, 4, 5. Then we have successfully started the array. Let me tell the algorithm. So first we are starting from the second element. So the second element, so we are started with the second element 3 and later store current element. So we are storing current element. So compare it with the previous elements. Shift large elements one position right. So insert correct elements into the correct position. Repeat until the array is slotted. So this is the how insertion slot works. Let me write the time complexity for insertion slot. So I have written the time complexity for insertion slot. The best case is big O of n and the average case is big O of n square and the worst case is big O of n square also. So the worst case and average case is both same in time in insertion slot. The space complexity also same, big O of n, big O of 1. So the space complexity for insertion slot is big O of 1. So now let me tell the advantages. So advantages of insertion slot is it is easy to understand and easy to implement, work well for smaller data sets. So it requires a very little amount of memory. So the main disadvantages of insertion slot is slow for large data sets. Suppose there are 100 elements, it is very slow for large data sets. So it is not suitable for very large applications. That is the main disadvantage with insertion slot. So suppose let me give a real life example. Think about arranging books on a shelf. You pick one book at a time and place it in the correct position. So that is exactly how insertion slot works. So today we have learned what is insertion sort, step by step working algorithm, and time complexity. I hope this lecture is clear to everyone. If you have any doubts, you can ask in the comment section. So thanks for watching and see you guys in the next lecture.